Welcome to this quiet space, a gentle sanctuary where stories are woven to help you drift into a peaceful sleep. Tonight, we begin a journey together, an exploration into the profound and ancient stillness of mountains. We will travel not with our feet, but with our minds, venturing into the heart of stone, across the vastness of deep time, to feel the immense and calming presence these silent giants offer to the world. Before we embark on this gentle exploration, I would love to know where you are listening from this evening, or perhaps what mountains you have seen or dreamed of. Feel free to leave a quiet comment below. And if you find comfort in this space, please consider supporting our journey with a like and a subscription to the channel. Your quiet companionship means the world. Thank you. Now, allow yourself to settle in. Let your body grow heavy, your breath find its own slow, deep rhythm, and let the world outside simply fall away as our story begins. Let us start our journey not on a windswept summit, nor in a deep, shadowed valley, but with something small enough to hold in the palm of your hand. Imagine, if you will, a single stone. Feel its weight, its substance, the cool, solid reality of it resting against your skin. Its surface might be smooth, polished by the patient caress of a river over countless seasons, or it might be rough and crystalline, its edges sharp with the memory of a recent fracture. This small object, this fragment of the world, is our entry point into a story of almost unimaginable scale. It is a key, a single word from which we can learn the language of the earth itself. This is the heart of geology, which is not merely the study of rocks, but the art of reading the planet's autobiography, an epic written in a script of stone and time. And like any great story, it begins with its most fundamental characters. The first are the igneous rocks, born of fire, forged in the violent creative heat of the planet's core. Imagine liquid rock, magma, churning in the deep darkness, a substance hotter than any earthly flame. When this molten material cools and solidifies, either bursting forth in a volcanic eruption or cooling slowly in the silent, pressurized depths, it becomes igneous rock. It is the primal foundation, the very bedrock of our world, a cooled memory of the Earth's fiery youth. Then there are the sedimentary rocks, the children of water and air. Picture the great mountains, which we will soon explore, being constantly, patiently, unmade by the wind and the rain. Tiny grains of sand, particles of dust, and fragments of shell are washed down by rivers into lakes and oceans, settling layer upon layer upon layer. Over millions of years, the immense pressure of the water above and the slow chemistry of minerals dissolved within it cement these loose particles together, transforming them into solid rock, like sandstone, limestone, or shale. Each layer is a page in a history book, a thin stratum holding the fossilized echo of a particular moment in time, the whisper of an ancient sea, the shadow of a long-extinct fern. And finally, there is the third great family, the metamorphic rocks. These are the rocks of transformation. They are not born of new material, but are older rocks, either igneous or sedimentary, that have been profoundly changed. Imagine a slab of limestone, born in a shallow sea, being dragged deep into the earth by the slow collision of continents. Down in the darkness, it is subjected to unimaginable heat and pressure. Not enough to melt it completely, but enough to cook it, to squeeze it, to force its very atoms to rearrange themselves into new, more stable crystalline structures. The soft, humble limestone is reborn as hard, shimmering marble. A muddy shale, under this same alchemical pressure, can transform into a sleek, dark slate. Metamorphism is the story of resilience, of a substance becoming something new and beautiful not by being destroyed, but by enduring. Now, bring your awareness back to that stone resting in your hand. Let us imagine it is a piece of granite, one of the most common and noble of igneous rocks. Look closely at its surface. It is not a single, uniform color, but a mosaic, a community of different minerals locked together in an ancient embrace. You see the milky, translucent grey of quartz, a crystal made of silicon and oxygen, SiO2, the most abundant elements in the Earth's crust. Its structure is so strong, so perfectly ordered at an atomic level, that it resists erosion, often remaining as grains of sand long after the rest of the granite has weathered away. You also see the creamy, opaque shapes of feldspar, another silicate mineral, which gives the granite its body and often a pink or white hue. And scattered amongst them, you see tiny, glittering flakes of mica, black or silver, catching the light like captured stars. These thin, fragile sheets are a testament to the slow, undisturbed cooling that allowed each mineral to form according to its own nature, to find its own space within the whole. This single piece of granite is not just a rock, it is a society of crystals, a frozen moment from a time when the world was still cooling. It tells a story of a slow journey from a liquid state, a gradual hardening into the form you now hold. And as you feel its weight, its dense and quiet presence, allow your mind to drift into the most profound quality this stone possesses: its age. The granite in your hand was likely not formed 1,000 years ago, or even 1,000,000. It is probably hundreds of millions, or in some parts of the world, billions of years old. Before the first dinosaurs, before the first complex life crawled from the oceans, before the atmosphere held the oxygen we breathe, this stone was already old. It existed in a world we can barely imagine, a silent, alien planet of rock and water. To hold it is to hold a piece of what is known as deep time, a scale of existence so vast that our own human lives, our entire history, feel like a fleeting spark against its immense, dark backdrop. The atoms within it have been locked in their crystalline embrace, still and silent, while empires have risen and fallen, while languages have been born and forgotten, while entire species have appeared and vanished from the face of the earth. It does not measure time in hours or centuries, but in eons. It does not hurry. It simply is. And in its silent, patient being, it offers a profound sense of peace. It is a connection to something eternal, a quiet testament to an age so vast it defies imagination, all held within the palm of your hand. And if such an eternity can be held in a single stone, imagine the story that unfolds when we let our awareness expand, rising up from that small point of contact to embrace the whole colossal form from which it came. The stone in our hand is not an orphan, it is a child of the mountain. And the mountain itself is a child of forces so great they beggar belief, forces that operate on the scale of the entire planet. To understand the great stillness of mountains, we must first appreciate the unbelievably slow and powerful motion that gives them birth. The solid ground beneath our feet feels firm, permanent, a symbol of stability. But this is an illusion born of our fleeting human timescale. In the grand sweep of geologic time, the surface of our world is not a static crust, but a dynamic mosaic of immense, interlocking plates, known as tectonic plates. These plates, which make up the Earth's lithosphere, are dozens of kilometers thick and can be the size of entire continents. They are not fixed in place, but are constantly, slowly, drifting across the semi-molten layer of the mantle beneath them, moving no faster than our fingernails grow. For millions upon millions of years, this silent, inexorable dance continues, a planetary ballet whose movements are imperceptible to us, yet powerful enough to shape the very face of the world. This grand process of mountain building, known to geologists as orogenesis, is perhaps the most dramatic expression of plate tectonics. It is the earth breathing, a long, slow inhalation and exhalation that plays out over eons. The most spectacular mountains are born at what are called convergent boundaries, places where two of these colossal plates are on a collision course. Imagine two immense rafts, each carrying a continent, drifting towards each other across a vast ocean. For millions of years, the ocean floor between them is slowly consumed as one plate slides beneath the other. But eventually, the continents themselves meet. And continental crust, being thick and buoyant, cannot be easily forced down into the mantle. So when two continents collide, there is nowhere for the rock to go but up. The edges of the plates begin to crumple, to buckle, and to fold. The layers of sedimentary rock that once formed the floor of a shallow sea are squeezed, fractured, and thrust violently skyward. What was once horizontal becomes vertical. The pressure is so immense, the force is so titanic, that the rock deforms like clay, folding into vast, wave-like shapes or breaking along massive fault lines and being stacked one on top of the other. This is the story of the Himalayas, the greatest mountain range on Earth. They are the living, breathing result of a slow-motion collision between the Indian plate and the Eurasian plate that began some 50 million years ago. India, once an island continent, drifted northwards across the ancient Tethys Ocean until it made contact with the southern edge of Asia. Since that moment, it has continued to push relentlessly northward, driving itself under the Eurasian plate and forcing the Tibetan Plateau and the Himalayan peaks ever higher. The mountains are still rising today, growing by a few millimeters each year, a subtle movement that is the ongoing echo of that colossal impact. When we look at a peak like Mount Everest, we are not seeing a static, permanent object. We are seeing a single frame in a continuous process of uplift, a wave of stone cresting in ultra-slow motion. The limestone found at its summit was formed from the fossilized remains of marine creatures at the bottom of that ancient ocean, lifted nearly 9,000 meters into the freezing thin air of the upper atmosphere. The mountain is a monument to a buried sea, a testament to the power of a process that is still, silently, at work. And yet, how can something so massive, a collection of rock weighing trillions upon trillions of tons, rise so high against the constant pull of gravity? The answer lies in a beautiful principle of balance known as isostasy. The Earth's lithosphere, the rigid crust of the continents, is less dense than the semi-molten asthenosphere of the mantle upon which it rests. Therefore, much like a great wooden ship or an iceberg floating in water, the continental plates are buoyant. A mountain range has a deep root that extends down into the mantle, displacing the denser material below, providing the upward buoyant force that supports its immense weight. The taller the mountain range, the deeper its root must be, just as the visible part of an iceberg is only a fraction of its total mass, the majority of which is hidden beneath the waves. This means that a mountain range is in a constant, delicate state of gravitational equilibrium. As the peaks are slowly worn down by erosion over millions of years, their weight lessens. In response, the entire range slowly and gradually rises, bobbing up from the mantle below to restore the balance. This isostatic rebound is a deep planetary sigh, an adjustment that happens on a timescale far beyond our own, ensuring that even as the mountain is being worn away, its core continues to rise, a silent dance of mass and buoyancy. And so, the mountain is born, a colossal structure of folded and faulted rock, thrust into the sky by the slow breath of the planet, and held there in a state of perfect, silent balance, waiting for the next chapter of its long and patient story to unfold. But this perfect balance is not one of serene inaction, but a dynamic and eternal tension between two colossal forces. The first is the immense, patient push from below, the tectonic breath that lifts the continents. The second, which begins the very moment the first rock is exposed to the sky, is the equally patient, persistent, and creative force of erosion. Erosion is not destruction. It is the art that gives a mountain its character, its soul. The raw, jumbled mass of uplifted rock is merely the block of marble. Erosion is the sculptor's hand that will work for millions of years to reveal the masterpiece sleeping within. This sculpting is done not with one tool, but with three, each with its own gentle, yet relentless, technique. The first and most constant artist is water. Imagine the first rains falling on a newly risen mountain range. A single drop lands, then another, and another. They gather into tiny rivulets, seeking the path of least resistance, following the slightest crack or weakness in the stone. These rivulets merge into streams, and the streams into powerful rivers, and with every passing moment, they perform their slow, abrasive magic. A river does not carve a canyon with the force of its own water, but with the tools it carries. The sand, pebbles, and boulders that tumble along its bed, acting as a liquid sandpaper that grinds away at the bedrock, year after year, millennium after millennium. It is a process of infinite patience, slowly deepening its channel, creating the characteristic V-shaped valleys that slice through the heart of the mountains. Their steep sides a testament to the persistent, downward-cutting power of flowing water. Water possesses another, more subtle power, especially in the high, cold places. This is the simple magic of freezing. During the day, meltwater seeps deep into the smallest fissures in a rock face. As night falls and the temperature plummets, this water freezes and expands, exerting a pressure of thousands of pounds per square inch from within the stone itself. This process, known as frost wedging, acts like a tiny, silent jackhammer, widening the crack ever so slightly. Night after night, season after season, the cycle repeats. The crack grows, until eventually, a piece of the mountain, whether a small flake or a giant boulder, breaks free and tumbles down the slope. And the water that performs this physical work also engages in a quiet, chemical dialogue with the stone. The very rain that falls is slightly acidic, having absorbed carbon dioxide from the atmosphere to form a weak solution of carbonic acid. This gentle acid is enough to slowly dissolve certain minerals, especially in rocks like limestone, breaking the chemical bonds that hold the rock together. It is the gentlest of touches, a chemical whisper that, over the course of geologic time, can dissolve entire mountain ranges. The second great sculptor is ice. When we picture a glacier, we often see it as a static, frozen river. But a glacier is a river, and it flows with a power that liquid water can never match. In the high basins of the mountains, snow accumulates year after year, its own weight compressing the lower layers into dense, heavy ice. When this mass of ice becomes thick enough, it begins to move under its own immense weight, flowing slowly downhill. As it moves, it plucks and tears huge blocks of rock from the mountainside and grinds them against the bedrock below. It is not a gentle polisher, it is a colossal gouge, a planetary-scale file that reshapes entire landscapes. The soft, V-shaped valleys, carved by rivers, are widened and deepened into dramatic, U-shaped troughs. At the head of the glacier, it carves out deep, armchair-shaped hollows known as cirques, and where several of these cirques eat into a mountain from multiple sides, they can leave behind knife-edge ridges called arates, or even create sharp, pyramidal peaks like the famous Matterhorn, a mountain sculpted to a point by the work of ancient glaciers. The third and most subtle sculptor is the wind. While it lacks the sheer force of ice or the persistence of water, the wind is the master of fine detail. Over thousands of years, it picks up fine particles of sand and silt and hurls them against the rock faces. This is aeolian abrasion, a natural sandblasting that can polish surfaces, carve delicate arches in sandstone, and etch intricate patterns into exposed rock. It is the final touch, the finishing work that softens some edges and sharpens others. And so, the mountain's form is born of this eternal dance. The tectonic forces push it upward, and the forces of erosion, water, ice, and wind patiently carve it down. The shape we see, the jagged peak, the sweeping valley, the sheer cliff face, is not a final form. It is a momentary equilibrium between uplift and decay, a dynamic sculpture that is constantly being created and uncreated at the same time, a silent, breathtaking piece of art shaped by the patient hands of the elements. And this magnificent form, sculpted over eons by water and ice, does not simply sit passively upon the landscape. Its very shape now begins to sculpt the invisible world around it. The mountain, a creature of solid stone, extends its influence deep into the fluid and ever-changing realm of the sky. It becomes a master of the atmosphere, a powerful engine that creates its own weather, dictates the fall of rain, and breathes with a slow, daily rhythm of wind. The story of this influence begins with a simple truth. A mountain is a barrier. Imagine a vast mass of air, warm and laden with moisture evaporated from a distant ocean, moving steadily across a flat plain. It flows like a wide, invisible river. But when this river of air encounters the immense wall of a mountain range, it cannot go through it. It has nowhere to go but up. This process is known as orographic lift, and it is the key to the mountain's power over the sky. As this parcel of air is forced to climb the mountain's slope, it moves into regions of lower atmospheric pressure. With less pressure pushing on it from the outside, the air expands. And just like the expanding gas released from a canister feels cold, this expanding air begins to cool. For every 1,000 meters it climbs, its temperature can drop by as much as 10 degrees Celsius. This cooling has a magical consequence. Warm air can hold a great deal of water vapor, the invisible, gaseous form of water. But cold air cannot. As our rising air mass cools, it eventually reaches a point, the dew point, where it can no longer hold all of its moisture. At this critical altitude, the invisible water vapor begins to condense into microscopic liquid droplets or ice crystals, clinging to tiny particles of dust or pollen in the air. Suddenly, the invisible becomes visible. Clouds are born. They form first as a soft mist clinging to the slopes, then swell into great, billowing cumulus clouds that cloak the peaks in white. As the air continues to rise and cool, these tiny droplets collide and merge, growing heavier and heavier until they can no longer remain suspended in the air. They fall. On the windward side of the mountain, the side facing the oncoming moist air, the gentle and persistent rain or snow begins to nourish the slopes. This is why these faces of a mountain are so often lush and green, covered in vibrant forests and meadows, alive with the water the mountain has drawn from the sky. But the journey of the air is only half complete. Having reached the summit and shed its watery burden, the now cool and dry air begins to descend the other side of the range, the leeward side. As it flows downhill, the process reverses. The air is compressed by the increasing atmospheric pressure, and this compression heats it up. This warm, dry, descending wind can be a powerful force, and it creates a phenomenon known as a rain shadow. The leeward side of the mountain receives almost no precipitation, as the air flowing over it has already lost all of its moisture. This is why you can so often find a temperate rainforest on one side of a mountain range, and a dry desert or arid steppe on the other. The Sierra Nevada mountains in California are a perfect example, with their western slopes covered in giant sequoia forests, while their eastern side gives way to the arid Great Basin Desert. The mountain has effectively kept the rain for itself, creating two entirely different worlds on a single landform. And so, the mountain breathes. It has a daily respiratory cycle of its own. During the day, the sun warms the rock of the slopes more quickly than the air in the valley. This creates a layer of warmer, less dense air near the ground, which begins to flow gently upslope, a warm, rising current known as an anabatic wind. As evening falls, the process reverses. The slopes cool down rapidly, chilling the air in contact with them. This cool, dense air then begins to drain downslope under the pull of gravity, flowing into the valley like a river of cold, a katabatic wind. This is the mountain exhaling, a slow, gentle, and predictable rhythm that governs the lives of the plants and animals that call its slopes home. It is a living, breathing entity, not just of rock, but of air and light and water, a silent conductor of the atmospheric orchestra. And on the stage set by this grand atmospheric orchestra, in the damp hollows shielded from the wind, and on the sun-warmed faces of the bare rock, the first quiet actors begin to appear. They are not the great trees or the delicate flowers that we might imagine. The first life to take hold on a mountain is far more humble, more patient, and in many ways, more miraculous. After the glaciers have retreated, leaving behind a landscape of scoured, sterile stone, or after a fresh landslide has exposed a new face of rock to the sky, the surface appears entirely inhospitable to life. It is a world of pure mineral, lacking the soil, the nutrients, and the structure that most plants require. And yet, life finds a way. It arrives as airborne spores, tiny and almost weightless, drifting on the winds the mountain itself has created. Where these spores land, a slow, tenacious magic begins. This is the world of the pioneer species, the first colonists of the stone. The lichens and the mosses. At first, they are almost invisible, a faint stain of green or grey or fiery orange upon the granite. But over years and centuries, they grow into intricate, beautiful patterns, like maps of forgotten continents painted across the rock. These humble organisms are not merely living on the stone, they are in an intimate and transformative dialogue with it. They are the next great agents of change, continuing the work of erosion on a microscopic scale in a process called biological weathering. The tiny, Root-like structures of a moss, called rhizoids, insinuate themselves into the smallest, most imperceptible cracks in the rock's surface. As they grow, and as they absorb and release water, they exert a subtle but constant physical pressure, minutely widening these fissures, continuing the patient work of the frost and ice. But the true alchemy lies with the lichens. A lichen is not a single organism, but a wondrous partnership, a symbiotic union of a fungus and an alga. The fungus provides the structure, a protective home that can cling to the bare rock and absorb and retain precious moisture from the air. The alga, in turn, performs the miracle of photosynthesis, using sunlight to create sugars that feed both itself and its fungal partner. Together, they can survive where neither could survive alone, a perfect metaphor for cooperation in the harshest of environments. And this cooperative entity actively digests the rock on which it lives. The fungal part of the lichen secretes weak acids, chemical compounds that ever so slowly dissolve the minerals of the stone. It is a process of extreme patience, leaching out essential nutrients like phosphorus and potassium directly from the crystalline matrix of the granite or basalt. The lichen is, in essence, eating stone, transforming the inert mineral world into the building blocks of the biological world. Over immense spans of time, the continuous life and death of these pioneer organisms begins to build something new. As lichens and mosses die and decompose, their tiny bodies mix with the mineral particles they have helped break free from the rock. This creates the very first, gossamer-thin layer of soil. At first, it is little more than a dusting in the cracks, a shallow substrate that can hold a little more water, a little more nutrient than the bare rock could. But it is enough. It is the crucial invitation for the next wave of life. Into this thin new soil, the seeds of tougher grasses and hardy alpine wildflowers can finally take root. Their roots, in turn, push deeper, breaking the rock further, and their eventual decay adds more organic matter to the soil, deepening and enriching it. This is the beginning of ecological succession, a slow, generational process where each community of life prepares the ground for the next, more complex community. The mountain, which was once barren stone, is slowly, patiently, clothing itself in green, a process that begins with the quiet, persistent work of the smallest and most resilient of beings. While this slow, tenacious miracle of life unfolds on the mountain's outer skin, an even older and more perfect order lies hidden deep within the stone itself. The patient work of the lichen reveals the rock's mineral nutrition, but its own intrinsic nature is a secret kept in the darkness, a world of silent, geometric perfection. Let us now leave the sunlit surface and the first stirrings of green, and allow our awareness to journey inward, to shrink down past the surface of the granite, past the individual grains of feldspar and mica, and into the crystalline heart of a single quartz crystal. Here, in the microscopic realm, there is no chaos, no disorder. There is only a vast, silent, and perfectly repeating pattern. This is the essence of a crystal, an atomic structure that is not random, but is instead a highly ordered, three-dimensional lattice, a tapestry of atoms woven with mathematical precision. The entire structure is built from a single, simple unit that repeats itself over and over again in every direction, creating a form of perfect, frozen harmony. It is the physical manifestation of a law, a quiet expression of the fundamental tendency of matter to seek its lowest, most stable energy state. Within our quartz crystal, the building block of this perfect lattice is a shape known as a tetrahedron. Imagine a single atom of silicon, and around it, arranged in a perfectly symmetrical pyramid shape, are four larger atoms of oxygen. The bonds connecting them are incredibly strong, forged deep within the cooling earth. This tiny, fundamental unit, one silicon atom bonded to four oxygen atoms, is the repeating motif of our crystal. Each of the four oxygen atoms is also shared with a neighboring silicon atom, creating an interlocking network of tetrahedra that extends outwards in all directions. It is an architecture of immense strength and stability, which is why quartz is such a hard and durable mineral, often the last to be broken down by the forces of erosion. The stillness inside this crystal is absolute. Each atom vibrates gently in its fixed position, but it is held in a powerful embrace by its neighbors, locked into a pattern that has remained unchanged for hundreds of millions of years. This sublime order was not achieved in an instant. It is a direct result of time and patience. The granite of which this quartz is a part was once a molten soup of magma, a chaotic fluid where atoms moved freely. But as it cooled, deep beneath the surface of the earth, it cooled with incredible slowness, perhaps over thousands or even millions of years. This slow cooling gave the atoms time to move, to jostle, to find their perfect partners, and to settle into the most stable, most ordered arrangement possible. They locked into place, one by one, building the perfect crystalline structure from the chaos of the liquid magma. If this same magma had erupted onto the surface and cooled in minutes, the atoms would have been frozen in place in a disordered, chaotic jumble, forming a volcanic glass like obsidian. The beauty and perfection of the crystal, its clarity and strength, are a testament to the creative power of a slow, gentle, and undisturbed process. This principle of order emerging from chaos extends into the realm of metamorphic rocks as well. Imagine now a simple piece of shale, a sedimentary rock formed from compressed mud, its atoms arranged in a messy, disorganized way. If this shale is buried deep within the crust during the collision of two continents, it is subjected to a truly transformative experience. The pressure becomes immense, squeezing the rock from all sides, and the temperature rises until it is baked, but not melted. Under this intense heat and pressure, the atoms within the shale are forced to break their old bonds and migrate, rearranging themselves into a new, more compact, and more stable configuration. From the dull, grey mudstone, a new and beautiful mineral can be born. Garnet. The scattered atoms of aluminum, silicon, iron, and oxygen are forced by the laws of physics and chemistry to assemble themselves into the beautiful, 12-sided shape of a garnet crystal. It is a star of deep red or brown, born not in fire, but in the crushing, silent pressure of the deep earth. And so, the mountain's heart is not just solid, brute stone. It is a silent, hidden universe of geometric perfection, a vast library of crystalline forms, each one a testament to the immutable laws of nature and the profound, creative power of immense time and pressure. But the stillness of the mountain is not always the perfect, motionless order of a crystal. There is another kind of stillness, a profound quiet that masks an immense and patient power, a stillness that flows. This is the paradox of the glacier, the river of ice. From a distance, the glacier appears as a static feature of the landscape, a permanent fixture of white and blue, as solid and unmoving as the rock around it. Yet this serenity is an illusion, a trick of our human perception of time. For the glacier is always moving, flowing downhill under its own colossal weight with a silent, inexorable creep. It is a river, but one whose movement is measured not in meters per second, but in centimeters per day, a pace so slow that its motion is completely invisible to the naked eye, yet so powerful it can reshape the very bones of the earth. The story of this flowing ice begins not with power, but with delicacy, with the fall of a single snowflake. In the highest, coldest basins of the mountains, known as accumulation zones, the snow that falls in winter does not fully melt in the summer. Year after year, new layers of snow bury the old, and the weight of the overlying snow begins a slow and profound transformation. The delicate, six-sided crystals of a snowflake, so full of empty space, are compressed, their intricate arms breaking apart. They become small, granular pellets of ice. This intermediate state, no longer snow but not yet glacial ice, is called firn. As centuries pass and the layers deepen, the pressure becomes immense. The firn grains are squeezed even closer together, the last pockets of air between them forced out, and the grains recrystallize, growing larger and interlocking into a single, solid mass of dense, blue ice. The color of deep glacial ice is not an illusion. Because it is so dense and free of air bubbles, it absorbs the longer, redder wavelengths of light and reflects the shorter, bluer wavelengths, giving it a luminous, sapphire hue. This process mirrors the formation of metamorphic rock, a transformation driven by immense and sustained pressure, turning something light and airy into something of immense density and weight. When the ice reaches a critical thickness, typically around 50 meters, the pressure on the layers below is so great that the ice begins to deform and move. This movement happens in two beautiful and distinct ways. The first is called plastic flow, or internal deformation. The ice, which we think of as a brittle solid, behaves like an incredibly thick, viscous fluid under this immense pressure. The very crystals of the ice begin to stretch, to deform, and to slide past one another, allowing the entire glacier to flow from within, like a river of ultra-thick honey. The surface of the glacier, being under less pressure, remains brittle and often forms deep cracks called crevasses as it is stretched over uneven terrain, but deep inside, the ice is in constant plastic motion. The second method of movement is basal sliding. In many glaciers, the immense pressure and the friction with the bedrock below generate enough heat to melt a thin layer of ice at the glacier's base, creating a film of water that acts as a powerful lubricant, allowing the entire mass of the glacier to slide forward over the rock it rests upon. And as it moves, this river of ice becomes the most powerful tool of erosion on the planet. Its base is not clean, smooth ice. It is studded with rocks and boulders that have been torn from the mountainside or have fallen onto its surface and been carried deep within. These embedded rocks act like the teeth of a colossal file. As the glacier flows, these teeth grind against the valley floor, a process known as abrasion, scratching and pulverizing the bedrock, leaving behind long, parallel grooves called striations that serve as a permanent record of the direction of the ice's ancient flow. The sheer weight and force of the moving ice can also break off and tear away huge chunks of rock from the ground in a process called plucking. This combination of grinding and tearing allows a glacier to carry away millions of tons of rock, widening valleys, deepening basins to form future lakes, and sculpting the mountains into the dramatic forms we saw before. The great stillness of the glacier is therefore a lie, but a beautiful one. It is the stillness of immense, contained power, the quiet of a force so patient its movement is imperceptible, yet so strong it can wear a mountain to dust. It is suspended time, a slow-motion memory of every winter's snowfall, flowing ever downward to shape the world. And in the magnificent, raw landscapes left behind by these retreating rivers of ice, in the wide, U-shaped valleys and the sheltered, sun-facing cirques, life returns with a quiet and astonishing resilience. The mountain, having been sculpted by the immense forces of tectonics and ice, now becomes a canvas for the delicate artistry of biology. To explore the life of a mountain is to take a journey upward, through a series of distinct and beautiful worlds, each with its own climate, its own challenges, and its own unique community of inhabitants. This layering of ecosystems is known as altitudinal zonation, and it transforms the mountain into a vertical garden, a continent in miniature. Let us begin our ascent at the mountain's base, in the temperate world of the foothills. Here, in the montane zone, the soil is often deep and rich, the air is mild, and life is abundant. We walk through a familiar deciduous forest of oak, maple, and beech, their broad leaves forming a dense canopy that dapples the sunlight on the forest floor. The air is thick with the scent of damp earth and decaying leaves, and the sounds are of birdsong and the rustle of small animals in the undergrowth. This is the most productive and diverse of the mountain's worlds, a gentle and welcoming start to our journey. As we climb higher, the air begins to thin and cool. The broadleaf trees, with their delicate leaves, begin to disappear, replaced by a hardier community of conifers. We enter a forest of pine, spruce, and fir, their needle-like leaves perfectly adapted to conserve water and shed heavy snow. The forest floor is now carpeted, not with soft leaves but with a springy layer of shed needles, and the air carries the sharp, clean scent of resin. The world has become quieter, more severe, yet it holds its own stark beauty. Life is more specialized here. We might find the tracks of a deer or a bear, animals well adapted to the colder winters, and the different sources of food this forest provides. Continuing our ascent, we approach a great and dramatic boundary, the tree line. Here, in the subalpine zone, the forest wages a constant battle with the elements. The relentless wind, the short growing season, and the thin, rocky soil make life for a tall, upright tree almost impossible. The trees that do survive are transformed, becoming low, twisted, and gnarled, their branches often growing only on the side, sheltered from the wind. This is the Krumholtz effect, German for crooked wood, a visible testament to the struggle for survival. Finally, we push past these last arboreal outposts and step out into a new world. Above the tree line, there is only the sky, the rock, and the low-lying vegetation of the alpine tundra. Here, in this seemingly harsh and empty world, life does not just survive, it thrives, but in new and ingenious forms. The plants have abandoned the strategy of growing tall, and instead hug the ground for warmth and protection from the wind. We find beautiful cushion plants, which grow in low, tight, hemispherical mounds that act like tiny greenhouses, trapping heat and moisture within their dense foliage. Alpine flowers, like the forget-me-not or the saxifrage, bloom with an intense, vibrant color to attract the few pollinators that brave these heights during the short summer. Their roots run deep into the rocky soil, anchoring them against the wind, and their leaves are often small and covered in fine hairs to reduce water loss in the dry, thin air. The animals that live here are supreme specialists. The mountain goat, with its unique cloven hooves that have a hard outer edge and a soft, pliable inner pad, can grip the smallest of rock ledges with the dexterity of a ballet dancer. Mammals that live at these high altitudes, from the marmot to the Andean llama, have evolved profound physiological adaptations to survive in the oxygen-poor air. Their bodies have larger lungs, and their blood is filled with more red blood cells and a specialized form of hemoglobin that is incredibly efficient at capturing and delivering what little oxygen the atmosphere provides. They are living embodiments of the mountain's challenge, their very blood and bone shaped by the altitude. Their existence, a quiet victory over the thin, cold air of the high peaks. And yet, for all the vibrant life that clings to its surface, for all the drama of the wind and clouds that play about its peaks, the deepest truth of the mountain seems to be one of profound silence. In the high places, far from the noise of the human world, the quiet can be so absolute that you feel you can hear the universe itself. But this silence is a gentle deception, a limitation of our own human senses. The mountain is not truly silent. It is, in fact, constantly alive with a symphony of sound, a deep and resonant song of stone, but it is played at a frequency far too low for our ears to ever perceive. We are simply not built to hear the music that the planet makes. To listen to this deep song, we need a different kind of ear, the ear of a seismologist. We tend to think of seismology as the science of violent earthquakes, but it is more accurately the art of listening to the subtle vibrations that are constantly coursing through the Earth's crust. A seismometer is like a planetary stethoscope, a sensitive instrument that can detect the faintest of tremors, the most subtle of planetary heartbeats, and translate them into a language we can understand. What these instruments tell us is that our planet is never truly still. It is filled with a constant, low-level vibration known as a microsysm. This is the background hum of the Earth, a ceaseless tremor generated by the collective energy of our world. It is the rumble of distant ocean waves crashing on a shoreline 1,000 miles away, the energy of their impact traveling through the solid rock. It is the vibration of strong winds blowing over entire continents, the pressure of the moving air causing the crust itself to flex and tremble. It is the collective noise of our own civilization, a faint, high-frequency tremor that travels outward from our cities. The mountain, being a vast and deeply rooted part of this crust, is constantly vibrating with this planetary hum. It is a passive resonator, gently trembling with the song of the distant sea and the whisper of the wind, a quiet participant in the Earth's background music. But beyond this gentle, ever-present hum, the mountain also has a voice of its own, a voice that speaks in the language of infrasound. Infrasound is the realm of deep vibration, sound waves with a frequency below 20 Hz, the lowest threshold of human hearing. While we cannot hear them, these powerful, long wavelength sounds can travel for immense distances through the rock and the air. And it is in this deep, inaudible register that the most profound geological events express themselves. The slow, grinding movement of a tectonic plate deep beneath the mountain's roots, the groaning of rock under immense stress, is not silent. It generates a deep, continuous infrasonic drone. A glacier, which seems to move without a sound, is in fact incredibly noisy in this low frequency, with the cracking of its internal ice and the grinding of its base against the bedrock, producing a constant, deep rumble. A great rockfall or an avalanche does not just produce the audible crash and roar that we might hear. It releases a massive pulse of infrasound that is its true voice, a wave of pressure that can be detected hundreds of miles away. This is the song of the mountain itself, the sound of its own slow creation and its own patient decay, a music of immense and powerful events unfolding on a timescale far grander than our own. The mountain is a geological instrument. Its complex internal structure of faults, fractures, and varying rock densities shaping the vibrations that pass through it, perhaps dampening some frequencies and amplifying others, giving its own unique timbre to the deep song of the earth. Its great stillness is not an absence of sound, but a fullness of a sound so deep and so vast, it holds the story of the planet itself. And this deep, resonant song of stone is not the only secret the mountain holds within its heart. For through its deep fractures and hidden passageways, another invisible world is in constant, silent motion, a world of water, heat, and slow, patient alchemy. Deep beneath the mountain's peaks, miles below the surface, the rock is hot. This is the Earth's geothermal gradient, the natural increase in temperature as one descends toward the planet's molten core. In areas of past or present volcanic activity, this heat is even more intense, with great chambers of magma still slowly cooling from a time of ancient fire. When groundwater from the surface seeps down through cracks and pores in the rock, it eventually reaches these heated depths and begins a profound transformation. Under the immense pressure of the overlying rock, this water can be heated to hundreds of degrees Celsius without ever boiling. It becomes a substance known as a supercritical fluid, a strange and powerful state between a liquid and a gas, and it is one of the most effective solvents in nature. This superheated, high-pressure water is the lifeblood of a hidden geological process. It is forced through the microscopic fissures and cracks of the deep rock, and as it travels, its incredible solvent power goes to work. The rock it passes through, which might be ordinary granite or shale, contains trace amounts of precious and rare elements, atoms of gold, silver, copper, or zinc, scattered so sparsely that they are of no consequence. But this hungry, superheated water leaches these atoms from the crystalline structures of the host rock, dissolving them into solution, gathering them up one by one. Over thousands of years, the water continues its journey, carrying its precious, invisible cargo of dissolved minerals, flowing through a vast and intricate network of fractures like a hidden circulatory system within the mountain. It follows the paths of least resistance, always seeking a way upward, toward regions of lower pressure and lower temperature. And as this mineral-rich fluid ascends, its journey reaches a creative climax. As it moves into cooler regions of rock, or perhaps into a larger, more open fissure where the pressure suddenly drops, the conditions change. The water, now cooler and less pressurized, can no longer hold its heavy load of dissolved minerals. It becomes supersaturated, and so the minerals begin to precipitate out of the solution, crystallizing onto the cold walls of the rock fracture. It is a slow and beautiful process. First, a layer of milky white quartz might form, the most common of the dissolved minerals. Then, as the temperature and chemistry of the fluid continues to change, perhaps a glittering layer of iron pyrite, or fool's gold, will be deposited. And within this quartz, if the conditions are just right, thin, luminous threads of pure, native gold will crystallize, solidifying from the water that carried them. Layer upon layer, mineral upon mineral, the process continues, for centuries, for millennia, until the entire fracture is filled with a solid band of new, crystalline material. A vein is born. And so, deep within the dark, solid rock, a secret and beautiful architecture is created. The mountain's interior is crisscrossed with these ribbons of crystallized light, veins of quartz laced with gold, silver, or other treasures. They are not just geological formations. They are the frozen memory of an ancient, flowing river, a testament to the mountain's hidden, alchemical heart a quiet process that gathers the diffuse essence of the stone and concentrates it into a form of startling and unexpected beauty. But the mountain's relationship with water is not only a story of the deep past, of heat and pressure and alchemical transformation. It is also a living, breathing story that unfolds with every season. A story of cold, pure water that brings life, not just to the stone, but to the entire world that lies in its shadow. The mountain is the great water tower of the planet. Its high peaks reach up into the cold, moist currents of the atmosphere, combing the water from the clouds and gathering it, first as snow, then as ice, and finally as the clear, cold liquid that is the foundation of so much of life on Earth. This process begins in the quiet cold of winter. As storm clouds, forced upward by the mountain's own mass, release their burden, it falls not as rain but as snow. Billions upon billions of delicate ice crystals accumulate on the high peaks and in the sheltered basins, forming a deep and brilliant white blanket. This is the snowpack, and it is far more than just frozen water. It is a vast, natural reservoir, a battery of life-giving moisture, charged during the cold months and held in trust for the warmer seasons to come. In the depths of winter, this water is locked away, and the rivers in the valleys below may run low. But as the sun grows stronger in the spring, the great melt begins. Slowly at first, and then with a gathering rush, the snowpack begins to release its stored treasure, feeding a steady and reliable flow of cold, fresh water into the streams and rivers, just when the ecosystems and the farmlands of the lowlands are awakening from their winter slumber and need it the most. Let us follow the journey of a single drop of this water. It begins its life as a snowflake, resting for months in the silent, frozen community of the snowpack. When the spring sun finally warms it, it transforms into a liquid droplet and begins its long journey to the sea. Some of it may join with its neighbours and run directly off the surface, a fast-moving current of snowmelt cascading down the rocky slopes. But much of it takes a far slower, more intimate path. It seeps downwards into the mountain itself. The mountain, which seems so solid, is in fact a porous and fractured body. The water percolates into the thin alpine soil, trickles down through layers of gravel and sand left behind by ancient glaciers, and finds its way into the intricate network of cracks and fissures that run deep into the bedrock. Here, in the cool, dark interior of the mountain, it joins a vast, slow-moving underground reservoir known as an aquifer. Its journey now slows from a rush to a creep. It may spend years, decades, or even centuries travelling through these subterranean passageways. And as it moves, the mountain performs a final, vital act of service. The layers of sand, gravel, and porous rock act as a perfect natural filter, stripping away impurities, dust, and debris, purifying the water with a patience and effectiveness that no human technology can match. The water that enters the mountain may be simple snowmelt, but the water that leaves it is something else entirely. Eventually, its long, slow journey through the darkness comes to an end. At some point on the lower slopes, where a fissure meets the surface, the water emerges back into the light. It bubbles up from the ground as a spring, cool, clear, and enriched with the minerals it has dissolved from the rocks along its path. This is the purest of waters, a gift from the mountain's heart. And this spring is a beginning. It is the source of a small stream, which will be joined by countless other springs, each one a tiny artery of the mountain's circulation system. These streams merge to form creeks, the creeks merge to form rivers, and the path of these rivers is dictated by the very shape of the mountain itself. The high ridges and peaks form divides, creating immense drainage basins known as watersheds. All the snow and rain that falls within the boundaries of a watershed will be guided by the force of gravity into a single great river, a river that owes its entire existence to the mountain that stands at its head. The mountain is thus a benevolent parent, gathering the water of the heavens, holding it, purifying it, and then sending it out to nourish the world that lies below. And while the mountain generously sends its life-giving waters down to the valleys below, its highest peaks hold another kind of life in sacred isolation, creating worlds that are complete unto themselves. These high, remote summits, particularly when they rise from surrounding lowlands of desert or arid plains, become worlds apart, sanctuaries of evolution. They are known to biologists as sky islands. Imagine a vast, warm, dry sea of desert, an environment hostile to creatures that need coolness and moisture to survive. Rising from this sea are the great, isolated mountain ranges. Their cool, forested slopes and damp, high-altitude meadows, forming islands of habitable terrain. For the plants and animals that are adapted to the cold, thin air of the heights, the journey from one mountain peak to the next, across the deadly expanse of the desert floor, is an impossible one. The populations on each sky island are therefore completely isolated from one another, as marooned as if they were on a true island in the middle of the ocean. And it is this profound isolation that becomes a quiet, powerful engine of creation. This process is a beautiful illustration of island biogeography, the study of how life evolves in isolated places. Let us imagine a time long ago, during a cooler and wetter period, perhaps a great ice age. The climate of the lowlands was much like the climate of the mountaintops today. Forests of pine and spruce might have stretched across the entire region, and a single, widespread species, perhaps a small chipmunk or a wildflower, lived happily throughout this vast, continuous habitat. But then, the climate began to change. The world warmed, the great ice sheets retreated, and the lowlands grew hotter and drier. The cool, moist forest began to die off in the valleys, retreating ever higher up the slopes of the mountains, where the temperatures remained cool enough for it to survive. The single, vast population of our chipmunk or wildflower was now fragmented, broken apart into a series of small, disconnected populations, each one stranded on its own mountain peak, its own sky island. The warm desert between them had now become an uncrossable barrier. Once this isolation is complete, the slow magic of evolution begins. The population on each island begins its own unique journey. The environment on one mountain might be slightly wetter, on another slightly rockier. The available food sources might be different. By pure chance, the collection of genes in one population will be slightly different from another. Over thousands of years and countless generations, each population adapts to its own specific circumstances. The chipmunks on one island might evolve a slightly thicker coat, or a different color of fur to blend in with the local rock. The wildflowers on another might evolve a slightly longer root system to find water, or a brighter color to attract a specific local pollinator. These small changes accumulate, generation after generation, until the populations on the different islands have diverged so much that they are no longer the same. They have become new, distinct species, a process known as allopatric speciation. The one ancestral species has become many, each one perfectly tailored to its island home. These new species are known as endemic, meaning they are found in this one specific place and nowhere else on Earth. The mountain has become a cradle of new life. The populations themselves are called relict, a living memory of a time when the climate was different and their ancestors roamed a much wider world. Each sky island is therefore a living museum, a sanctuary that not only protects life but actively creates it. Its isolation, a quiet testament to the endless, branching, and beautiful creativity of the natural world. But this delicate, isolated cradle of life, this sky island, exists in a constant and silent conversation with a force that is universal and inescapable, a force that dictates the shape of the island itself and the destiny of every grain of sand upon it. This is the force of gravity. It is so constant, so utterly pervasive in our lives, that we often forget it is there at all. Yet on a mountain, its presence is palpable. Gravity is the silent, unseen architect that gives the mountain both its immense potential energy and its ultimate fate. It is the source of the mountain's profound stillness. For this stillness is not an absence of force, but the result of the mountain's colossal effort to resist gravity's relentless, eternal pull. Every crystalline bond within the granite, every interlocking grain of sandstone, is locked in a state of tension, holding itself up against this fundamental law of the universe. The sheer mass of the mountain, trillions upon trillions of tons of rock, generates this immense internal pressure, the same pressure that can transform shale into slate and create garnets in the deep, dark rock. But the primary story of gravity is its simple, patient, downward summons. The mountain, from the moment it is born, is in a slow and constant process of unmaking itself, of answering gravity's call. This is the world of mass wasting, a term that encompasses all the ways in which rock and soil move downhill under their own weight. Sometimes, this movement is sudden and terrifyingly fast. A rockfall occurs when a single boulder or an entire cliff face, weakened by the slow work of frost and ice, finally succumbs to gravity and plummets into the valley below. A landslide is a greater, more chaotic event, a sudden collapse of a whole slope where soil, rock, and debris flow downward like a thick, unstoppable river. These events are dramatic, but they are rare. The true, constant work of gravity is far more subtle, a process so slow it is imperceptible to our senses. This is soil creep, the patient, millimetre by millimetre, downhill movement of the entire surface layer of the mountain. It happens as the soil freezes and thaws, expands and contracts with moisture, or is jostled by the roots of plants and the burrowing of animals. With each tiny disturbance, the particles of soil lift and settle, and gravity ensures they settle just a tiny fraction of an inch further downslope. We cannot see it happen, but we can see its effects in the slow, curved bending of tree trunks at their base, and in the leaning of old fence posts, all of which are slowly, inexorably, being carried downhill by this invisible current. On any loose slope, such as the great fields of scree and talus that accumulate at the base of cliffs, gravity dictates a beautiful and delicate state of equilibrium. The slope can only become so steep before it becomes unstable. This critical boundary, the steepest angle at which a pile of loose material can remain without sliding, is known as the angle of repose. It is a perfect physical expression of the tension between gravity's pull and the friction that holds the rocks in place. A slope resting at its angle of repose is in a state of poised stillness. It is stable, but only just. The slightest disturbance, a falling stone, a heavy rainfall, the step of a mountain goat, can be enough to trigger a small cascade, as the slope readjusts itself to find its moment of balance once more. Even the life on the mountain must obey this fundamental law. Plants exhibit a response known as gravitropism. No matter what angle the slope is, the roots will always sense the pull of gravity and grow downwards, seeking anchorage and water, while the stem will grow upwards, away from the pull, reaching for the life-giving light of the sun. This is why a forest on a steep hillside can look so magical, with the trunks of the trees curving gracefully as they correct their course to grow straight towards the sky. Gravity is the constant, the baseline against which all things on the mountain are measured. It is the force that holds the mountain together, and the force that will, over the course of eons, patiently pull it all apart, ensuring that every grain of sand eventually completes its journey back to the lowlands from which it was first raised. And yet, there is a force in nature that can defy this relentless downward pull, a power that comes not from the slow collision of continents but from the fiery heart of the world itself, a force that does not lift a mountain over millions of years, but builds one in a matter of days. This is the breathtaking and creative power of the volcano, the mountain born of fire. While most mountains are the result of compression and uplift, these are mountains of pure addition, new land created from the molten interior of our planet, a direct and violent challenge to the patient work of gravity. The story begins deep underground, in a vast reservoir of molten rock known as a magma chamber. This magma, a superheated slurry of melted silicate minerals and dissolved gases like water vapor and carbon dioxide, is the raw material of creation. It is less dense than the solid rock surrounding it, and so, like a hot air balloon, it is buoyant. It pushes relentlessly upwards, seeking any path of weakness, any fracture or conduit that might lead to the surface and to a release of its immense internal pressure. The personality of the mountain it will eventually build is determined entirely by the chemistry of this magma, its own unique character. Imagine first a magma that is very hot, low in silica, and therefore very fluid and runny, much like hot honey. This is basaltic magma. Because it is so fluid, the gases dissolved within it can escape easily. bubbling to the surface without building up extreme pressure. When this kind of magma reaches the surface, the eruption is typically gentle and effusive. Fountains of incandescent lava may jet into the air, but the main event is the quiet, steady outpouring of fiery rivers of lava that can flow for many miles across the landscape. Because the lava is so fluid, it spreads out in thin, wide sheets. Over the course of countless eruptions, these thin layers build upon one another, creating a vast, gently sloping mountain with a broad, rounded shape, like the shield of an ancient warrior lying on the ground. These are the shield volcanoes, the gentle giants of the volcanic world, like the Great Mauna Loa in Hawaii, the largest active volcano on Earth. Their birth is a quiet and steady construction, a gradual rising of new Earth from the sea of fire. Now, imagine a very different kind of magma. This one is cooler, much higher in silica, and as a result, it is incredibly thick and viscous, more like sticky tar than honey. This is silicic magma. Because it is so thick, the dissolved gases are trapped within it, unable to escape. As this viscous plug of magma rises towards the surface, the surrounding pressure decreases, and the trapped gases begin to expand violently, like shaking a bottle of soda and then suddenly opening it. The result is not a gentle flow, but a catastrophic, explosive eruption. The magma is torn apart into a towering cloud of hot ash, pumice, and gas that can rise tens of thousands of feet into the atmosphere. The thick, sticky lava that does erupt does not flow far, instead piling up close to the vent, cooling and solidifying into a steep-sided cone. Over time, alternating layers of explosive ash and thick lava flows build a tall, beautiful, and dangerously unstable mountain, the iconic, cone-shaped peak we so often associate with volcanoes. These are the stratovolcanoes, like Mount Fuji in Japan or Mount Rainier in the United States. Their birth is a thing of violent artistry, of terrifying and awesome power. And in the aftermath, when the eruption is over and a new silence falls, the cooled lava becomes new stone, new land. Basalt, pumice, and the black, glassy rock of obsidian cover the landscape. The mountain, whether born of a gentle flow or a fiery explosion, has asserted itself against gravity, a brand new structure of stone, now still and smoking, waiting for the first winds to bring the first spores of life. But whether a mountain is born in a sudden flash of fire or through the slow, patient crumpling of a continent, its presence on the landscape begins a new and far more subtle dialogue, a conversation not with the molten heart of the earth, but with the entire global atmosphere. The mountain, which appears to be a passive feature of the landscape, is in fact a profound and active participant in the long-term regulation of our planet's climate, a silent partner in the chemistry of the very air we breathe. This partnership takes place on two vastly different timescales, one biological and fast, the other geological and impossibly slow. The first is the role we can see and feel, the work of the mountain as the lungs of the planet. The great forests that clothe its slopes, from the deciduous woodlands at its base to the hardy conifers near the tree line, are engaged in the constant, quiet miracle of photosynthesis. They inhale the carbon dioxide from the atmosphere, the same gas that contributes to the warming of our planet, and through a beautiful alchemy powered by sunlight, they combine it with water and transform it into the solid wood of their trunks and the green of their leaves. The carbon that was once a gas in the air is captured, sequestered, and becomes part of the living fabric of the forest. And in return, as a gentle gift, they release the oxygen that all animal life depends upon. The mountain, through the life it supports, is constantly breathing in and breathing out, a vital organ in the planet's respiratory system. But this biological breath is only half of the story. The mountain's deepest contribution to the planet's health is far slower, a process written not in leaves and wood, but in the very chemistry of the stone itself. This is the Great Silicate Weathering Cycle, and it is perhaps the most important long-term climate regulator on Earth. As we have learned, the rain that falls on the mountain is naturally slightly acidic, a weak solution of carbonic acid, formed as the water mixes with atmospheric carbon dioxide. When this acidic rain falls upon the common silicate rocks that make up the bulk of the mountain, like granite and basalt, it triggers a very slow chemical reaction. The carbonic acid patiently dissolves the rock, breaking down its crystalline structure. This process releases calcium and other ions, but most importantly, it transforms the carbon dioxide that was in the rainwater into a new form, bicarbonate ions, which are soluble in water. These bicarbonate ions, carrying the carbon that was once a gas in the atmosphere, are then washed away by the streams and rivers, a steady, invisible export from the mountain to the sea. Once in the oceans, this is where the cycle completes its beautiful, life-sustaining loop. Marine organisms, from microscopic plankton to larger creatures like clams and corals, absorb these bicarbonate ions from the water and use them to build their shells and skeletons of calcium carbonate. When these organisms die, their shells drift down into the deep ocean, accumulating in thick layers of sediment. Over millions of years, this sediment is compacted and cemented into limestone, locking the carbon away in solid rock, where it may remain for hundreds of millions of years. This entire multi-stage process acts as the Earth's planetary thermostat. If the planet gets too warm, evaporation and rainfall increase, which speeds up the rate of silicate weathering. This, in turn, pulls more carbon dioxide out of the atmosphere, reducing the greenhouse effect and cooling the planet back down. If the planet gets too cold, weathering slows down, allowing the carbon dioxide released by volcanoes to gradually build up in the atmosphere, warming the planet back up. And the mountains are the absolute key to this system. The great tectonic uplifts of the last 50 million years, the rise of the Himalayas, the Andes, and the Rockies, exposed vast quantities of fresh, easily weathered silicate rock to the atmosphere. This massive increase in the planet's capacity for weathering is thought by many scientists to be the primary reason for the long-term cooling trend of our planet's climate, a slow and steady balancing act performed by the patient decay of the silent stone. And so we find the mountain to be a master of the planet's physical systems, a sculptor of landscapes, a regulator of climate, and a giver of life. But its greatest and most mysterious power may not be what it does to the world around it, but what it does to the world within us. This is where our journey turns inward, from the geology of the rock to the geography of the human soul. For as long as we have been human, we have looked to the mountains with a sense of reverence and wonder. Across nearly every culture, in every part of the world, mountains are sacred spaces. They are the homes of gods, the stairways to heaven, the places of pilgrimage and revelation. They are where prophets go to speak with the divine, where seekers go to find clarity, and where ordinary people go to feel a sense of peace that the lowlands can rarely offer. Why is this? Why does the silent, inanimate presence of a great mass of rock have such a profound and universal effect on the human spirit? The answer, it seems, lies in the powerful emotion of awe. Awe is the feeling that arises when we are in the presence of something vast, something that transcends our usual understanding of the world and forces us to recalibrate our perspective. A mountain, with its sheer physical scale that dwarfs our bodies, and its deep, geological timescale that dwarfs our lives, is one of the most powerful triggers of this emotion. When we experience awe, something remarkable happens to our sense of self. Psychologists call this the small self effect. In the face of such vastness, our own personal concerns, our anxieties, our ego-driven worries, all seem to shrink in significance. The pressing deadline, the argument we had, the anxieties about the future, they all lose their sharp edges, softened by the perspective offered by something so immense and so ancient. The mountain does not solve our problems, but it puts them in their proper context, revealing them to be as small and transient as they truly are. This feeling is closely related to the philosophical and aesthetic concept of the sublime. The sublime is an experience that mixes beauty with a sense of overwhelm, even a hint of fear or danger. It is the feeling of standing at the edge of a great cliff, or looking up at a towering, storm-shrouded peak, and feeling both our own fragility and a profound, exhilarating connection to the raw power of nature. It is a moment that takes us beyond simple pleasure and into a deeper state of being, where we feel truly, fully alive. There may even be an evolutionary echo in our love for mountains. The biophilia hypothesis suggests that we have an innate, genetically programmed affinity for the natural world, particularly for landscapes that offered safety and resources to our ancient ancestors. A mountain provides both. It is a source of clean water, its slopes are home to game, and most importantly, it offers a high vantage point, a place from which one can survey the surrounding landscape, spot danger, and find opportunity. Our deep feeling of peace and security in the mountains may be a whisper from our own deep past, a recognition of a place that has always meant survival. And now, modern neuroscience is beginning to confirm what poets and mystics have always known. When people are in states of awe, brain scans show a quieting of a region called the default mode network, which is the part of our brain responsible for self-referential thought, for the constant, chattering monologue of the ego. The mountain's great external stillness seems to invite a corresponding stillness within our own minds, quieting the noise and allowing for a more profound, less self-centered awareness to emerge. Our connection to these great, silent places is not just a poetic fancy, it is a fundamental part of our consciousness, a deep and resonant echo between the landscape of the planet and the landscape of the human heart. And perhaps this deep, quiet connection we feel is a form of recognition. A recognition that the mountain is not just a silent observer of the world, but a silent historian, an archive that holds the memory of time itself in its very substance, waiting patiently for a mind quiet enough to read its story. The mountain is a library, and its books are not made of paper and ink, but of stone, ice, and wood. To learn to see the mountain is to learn to read this magnificent, living archive of the earth. The grandest volumes in this library are the great cliff faces of sedimentary rock, laid down in layers over countless eons. The study of these layers, known as stratigraphy, is the art of reading the Earth's history, page by page. The most fundamental rule of this art is the principle of superposition, a beautifully simple idea that in any undisturbed sequence of layers, the oldest are at the bottom and the youngest are at the top. Each layer, or stratum, is a snapshot of a particular time and a particular environment. A thick band of sandstone might tell of a time when this place was a vast, windswept desert. A layer of dark shale, embedded with the faint outlines of ancient ferns, speaks of a quiet, swampy bog, and a layer of limestone is the ghost of a warm, shallow sea, built from the shells of creatures that lived and died hundreds of millions of years ago. To look at such a cliff face is to look at a timeline made manifest, a vertical journey through the lost worlds of our planet's past. And if the rock layers are the pages, then the fossils within them are the illustrations. A fossil is a whisper from a life long vanished, an echo of an existence captured and preserved in stone. The delicate, curled form of a trilobite, an armored creature that scuttled across the floors of ancient oceans 500 million years ago, tells a story of a world without flowers, without birds, without humans. The fossilized imprint of a leaf from a glossopteris tree, found in the rocks of Antarctica, South America, and India, tells the story of plate tectonics, of a time when these continents were all joined together in the great supercontinent of Gondwana. These are not just scientific curiosities. They are moments of connection, tangible proof that the world we know is just the latest chapter in an epic of unimaginable length, and that we walk upon a planet that is layered with the ghosts of countless other worlds. The mountain's archive is not confined to its rock. In its highest, coldest reaches, in the ancient ice of its glaciers, it keeps a more recent, but no less precious, record. Scientists can drill deep into this ice, extracting long cylinders known as ice cores, which contain a perfect, layered history of the atmosphere itself. Each year's snowfall creates a distinct new layer, and by counting these layers, we can create a calendar stretching back tens, or even hundreds, of thousands of years. But the true magic lies in what is trapped within the ice. Tiny bubbles of ancient air. These bubbles are perfect samples of the Earth's past atmosphere, allowing us to measure the precise concentration of carbon dioxide and other gases from long before our own time. The ice also traps layers of volcanic ash from distant eruptions, dust from ancient deserts, and pollen from long-vanished forests, creating a high-resolution diary of the planet's climate and condition, year by patient year. And finally, on the mountain slopes, The oldest living things on Earth keep their own private records. The great bristlecone pines, gnarled and weathered, can live for nearly 5,000 years. Each year, they add a new growth ring to their trunk, a ring whose thickness tells the story of that year's climate. A wide ring speaks of a good year, with plenty of rain and a long growing season. A narrow, constricted ring tells of a year of drought and hardship. This is the science of dendrochronology, and by studying the overlapping patterns of rings in living and dead trees, scientists can piece together a continuous record of regional climate stretching back over 10,000 years. The mountain is a historian that never forgets, its memory held in the fabric of its being, a silent and profound testament to all that has come before. To stand in the presence of such an archive, to feel the weight of these millions of years held in the silent stone, is to do more than simply learn about the past. It is to change our own relationship with the present moment. The great stillness of the mountain is not just an external, physical quality. It is an invitation to discover a similar stillness within ourselves. There is a profound parallel between the state of the mountain and the state of a meditative mind. The mountain stillness is not empty. It is a dynamic equilibrium, a perfect balance between the immense upward thrust of tectonic forces and the relentless downward pull of gravity. It is a state of immense energy, held in a perfect, serene poise. In the same way, the stillness of a calm mind is not a void, not an absence of thought, but a state of balance, where emotions and thoughts are allowed to arise and pass without disturbing a deeper, underlying sense of peace. The mountain is the external world's metaphor for the inner peace we seek. One of the most powerful ways the mountain invites us into this state is by altering our very perception of time. Our sense of time is not a constant, ticking clock. It is a subjective, fluid experience. When our minds are agitated, filled with anxious thoughts about the future or regrets about the past, time seems to speed up and slip through our fingers. The day is over before it has begun. But when we are calm, present, and deeply absorbed in the moment, time seems to expand, to slow down, to become deep and rich. By contemplating the mountain's timescale, what geologists call deep time, we can consciously shift our own temporal perspective. To hold in your mind the idea that the rock you are looking at is 400 million years old is to make the worries of the next 24 hours seem profoundly insignificant. The mountain's immense age provides a vast and calming context for our own fleeting lives. It does not erase our concerns, but it anchors us in a reality so much larger than them that they lose their power to dominate our minds. This is the very essence of mindfulness. To step out of the frantic stream of our own thoughts and to rest in a wider, more patient awareness. The mountain also teaches us a gentle philosophical lesson about permanence and impermanence. We look at its colossal form and we see a symbol of eternity, of something unchanging and everlasting. And yet, we know from our journey that this is an illusion. The mountain is in a constant state of unimaginably slow change, rising and eroding, being built and unmade in the same eternal moment. It is both permanent and impermanent. This paradox is a mirror for our own lives. We often strive for security, for a sense of permanence in our relationships, our careers, and our sense of self, while living in a universe that is fundamentally defined by change and flow. The mountain does not resist this truth, it embodies it. It teaches us that peace can be found not in fighting change, but in embracing a stillness that can exist within the flow. And finally, on a simple, sensory level, the very act of looking at a mountain can soothe our minds. The repeating patterns in its structure, the jagged silhouette of the ridgeline being echoed in the shape of a single boulder, the way a great valley branches into smaller ones, are examples of natural fractals. Neurological studies have suggested that viewing these complex yet orderly patterns has a measurable, stress-reducing effect on the human brain. The mountain's form is a kind of natural therapy, its visual complexity holding our attention and calming the restless chatter of our thoughts. Its stillness is not empty, but full of time, of balanced force, and of a deep, resonant beauty that calls our own minds home to a place of peace. And as our minds settle into this deep and quiet state, let us make one final ascent. Let us allow our awareness to drift upward, past the last of the hardy alpine flowers, past the final fields of permanent snow, to the very summit of the mountain, to stand on the border between the earth and the heavens. Here, on a clear and moonless night, the world falls away. The air is thin, crisp, and so clean it feels like a tangible presence. The silence is absolute, a deep and resonant quiet that seems to be the native language of the cosmos. Below us, the world is a sea of darkness, but above us, the sky is a luminous, overwhelming tapestry of light. The stars do not twinkle here. They shine with a steady, unwavering intensity, and the great, milky river of our own galaxy, the Milky Way, stretches from horizon to horizon, so bright it seems you could reach out and touch it. This breathtaking clarity is a gift of the mountain. Here, at high altitude, we are above the thickest, densest part of the Earth's atmosphere, above the majority of its dust, its moisture, and its turbulence that scatters and distorts the starlight in the lowlands. The mountain is a natural observatory, a place where the veil between our world and the universe beyond is at its thinnest. As we stand here, bathed in the light of these distant suns, we are drawn into the greatest of all deep times, astronomical time. The light that graces our eyes is not of this moment. Light, though it is the fastest thing in the universe, still takes time to travel across the immense, empty void of space. The starlight that is arriving at this mountain peak tonight began its journey long, long ago. The light from some of the nearest stars left on its journey during our own lifetimes. The light from the brilliant star Vega began its journey 25 years ago. The light from the beautiful star cluster of the Pleiades has been traveling for 440 years, since a time before the invention of the telescope that would reveal its true glory. And the faint, misty patch of light that is the Andromeda Galaxy, our closest galactic neighbour, is the light of 2.5 million years ago. That light began its journey when our own human ancestors were first walking the plains of Africa, long before our species had even learned to master fire. When we look up at the night sky, we are not seeing the universe as it is, but as it was, a vast and layered museum of the past. And here, on this high summit, a profound and beautiful meeting takes place. The ancient light of the cosmos, which has travelled for millions of years, finally ends its journey by falling upon the ancient stone of the earth, which has been waiting here for hundreds of millions of years. The deep time of the heavens touches the deep time of our world. The silence of space meets the stillness of the mountain. It is a moment of perfect, resonant connection. But the connection is deeper still, more intimate than we can possibly imagine. For every atom in this mountain that is heavier than hydrogen and helium, the silicon and oxygen in the quartz, the iron in the deep rock, the carbon in the tiny alpine flowers, was not created at the beginning of the universe. It was forged in the heart of a star. In the immense heat and pressure of a stellar core, simple elements were fused together to create more complex ones. And when that star reached the end of its life, it exploded in a brilliant supernova, scattering these newly created, life-giving elements across the galaxy. This stardust then coalesced, over billions of years, to form new stars, new planets, and eventually, this very mountain and our very bodies. The stone beneath our feet is made of stardust. We are made of stardust. The mountain and ourselves and the distant, shining stars are all, in the most literal sense, family. We are not just looking at the cosmos. We are a part of it, looking back at our own origins, a quiet and momentary flourishing of the universe's own consciousness. And holding this thought, this quiet and wondrous connection to the entire cosmos, we can now begin our gentle descent, carrying the peace of the summit with us as we slowly make our way back down into the soft and welcoming valley of sleep. Let your awareness drift down from that high, star-strewn peak, back into the realm of the whispering air, feeling its gentle, katabatic breath flowing down the slopes in the cool of the night. We drift down past the silent, alpine meadows, where the cushion plants are holding their warmth against the cold. Their sleeping forms a testament to the quiet resilience of life. We pass the invisible tree line and enter the deep peace of the subalpine forest, where the gnarled and ancient trees stand as patient sentinels in the darkness, their rings holding the memory of 1,000 seasons. As we continue our descent, we remember the mountain's heart, the hidden world of perfect, crystalline geometry within the stone, and the deep, slow song of the earth that vibrates through it. We remember the rivers of ice that once carved these great valleys, and the slow, alchemical rivers of hot water that painted the deep rock with veins of gold and quartz. We float down into the warmer, richer forests of the mountain's base, remembering its generosity, its role as a great water tower, sending its pure, filtered life down to the world below. And finally, we come to rest on the memory of a single stone, held in the palm of our hand, a small solid piece of the earth that contains within it the entire story of deep time and patient transformation. The story of the mountain is a story of cycles, the slow, rhythmic breath of the planet that lifts the rock to the sky, and the patient, gentle work of water and ice that wears it back down to the sea. The cycle of the seasons, from the deep stillness of the snowpack in winter to the rushing release of the spring melt, the great planetary cycles of water and carbon, of which the mountain is a vital and generous part. These rhythms are the heartbeat of our world, a steady and reassuring pulse that underlies all of change. And finding a connection to these great, slow rhythms can bring a profound sense of peace to our own hearts, a reminder that we too are part of this natural, flowing, and perfectly ordered world. The great stillness of mountains, we have learned, is not an emptiness. It is a profound fullness. It is the stillness of balanced power, of immense history, of patient creation, and ceaseless, gentle change. It is a stillness that is deeply, wonderfully alive, and you can feel a reflection of that same stillness within you now. It is in the quiet, steady rhythm of your own breath. Feel the gentle rise and fall of your chest, the slow, easy movement of air in and out of your body. This is your anchor to the present moment, your own personal rhythm, as reliable and as natural as the turning of the earth. There is nothing else you need to do, nowhere else you need to be. Simply rest here, in the quiet safety of your own being, and allow the gentle weight of sleep to settle over you. Allow the stories and images of our journey to dissolve into the peaceful darkness of your own deep and quiet rest. If you have enjoyed this journey and found a measure of peace here, I would be so grateful if you would consider leaving a like on this story and subscribing to our channel. Your quiet companionship on these gentle journeys is deeply appreciated. But for now, all that is left to do is to let go. Until we meet again, I wish you a truly deep and profoundly peaceful rest. Good night.